Hi everyone. Today we're going to be looking at our notes for law of cosines. To warm up, I want to take a look at this triangle here. Let's find the length of the hypotenuse C of triangle ABC below. Given that angle C is a right angle, side length AC measures B units, and side length BC measures A units. Okay, let's go ahead and label our triangle here. We know that angle C is a right angle, so let's go ahead and denote that. We know that AC measures B, that one's labeled, as well as BC is labeled A. The hypotenuse here, the side across from the right angle, is going to be C units in length. So if I wanted to find the length of this, I can write up an equation. We know that this is a right triangle, so we can use a Pythagorean theorem. A squared plus B squared is equal to C squared. Okay? Because these are arbitrary values, A, B, and C, this is as far as we can go. But know that we can plug in values for A and B, and that can help us find the hypotenuse, the length of the hypotenuse C. Okay, so this is true for right triangles. Pythagorean theorem always works for right triangles. But what if we don't have a right triangle? What if triangle ABC was non-right? It could be an obtuse triangle. It could be an acute triangle. Suppose we have, in this example, an acute triangle. This is just arbitrary value, so it could represent an obtuse triangle as well, just not drawn to scale. So to find C, there's a couple techniques that we can use. Well, we already know that we can use Pythagorean theorem if we have right triangles. Here we don't have any right triangles, but what we can do is we can drop an altitude from one of the vertices to the opposite side length. Okay? In other words, drop a perpendicular from one vertex to the opposite side length. I'm going to choose side length C, or I'm sorry, vertex C, and we're going to drop a perpendicular to side length AB. Okay? This is called an altitude, and it gives us the height of the triangle. So I notice that this breaks up this overall triangle ABC into two big right triangles. I also notice that it separates segment AB into two segments. Let's call that top segment, we'll call it X. Then that bottom segment must be the quantity C minus X. Okay? So we've got these two right triangles. Let's go ahead and use the Pythagorean theorem now. This top triangle here, I notice that we have two legs, X and H, where the hypotenuse is B. So setting up an equation, we have X squared plus H squared is equal to B squared. Likewise, we can do the same with the bottom right triangle. So we have two legs, the quantity C minus X, we have H, and then the hypotenuse A. So we can write an equation, the quantity C minus X squared plus H squared is equal to A squared. Okay? Let's go ahead and simplify that quantity C minus X squared. So we're going to multiply that out. This is a binomial squared. So we have C squared minus 2CX plus X squared. Don't forget that middle term. We're going to go ahead and bring down our H squared and our equals A squared. Okay? Well, there's something that I notice here. This quantity here, X squared plus H squared, we already know what this is, right? We have another equation that includes that expression, X squared minus H squared. So what we can do is we can substitute the equivalent expression, B squared, anywhere that we see X squared plus H squared. So we have C squared minus 2CX, and then plus our B squared. So that's that substitution there, equals A squared. I'm going to rearrange a few terms here. So we have B squared plus C squared. We have a positive B squared and a positive C squared. And we have a negative 2CX, and that's all equal to A squared. We're kind of stuck for now, but there's a few other things we can do with right triangles. So let's look at this top triangle. I notice that I'm going to look at angle A. We have three side lengths. We have X, we have H, and we have B, the hypotenuse. Well, if I have angle A here, with respect to angle A, I can set up a trig equation. We know SOHCAHTOA, right? That right triangle trig works here too. So let's look at, well, I notice that this equation over here doesn't have any h's, no heights. So let's see if we can come up with a trig equation that includes X and B with respect to angle A. So this side length X is the adjacent side to angle A, and B is the hypotenuse. Therefore, we can set up a cosine equation. Cosine of A is equal to the adjacent side X over the hypotenuse B. Solving for X, we can multiply both sides by B, and we get the equation B cosine A is equal to X. Now we can substitute this equivalent expression, B cosine A, anywhere that we see X. So in this other equation, we have b squared plus c squared minus 2cx, but instead of x, we're going to plug in b cosine a. Okay? And this right here, this is our law of cosines. I'm going to rearrange this, so just putting a squared on the left-hand side. A squared equals b squared plus c squared minus 2cb, or I'll call it bc. We'll write it in alphabetical order. 2bc cosine a. Okay? So this is our law of cosines. Because we used arbitrary values here, a, b, and c are just side lengths. They can be numerical values, they can be expressions. This equation here, this formula, law of cosines, works for all triangles, right, non-right, so obtuse, acute triangles, all of those. One thing to notice is that we can also rearrange the vertices and side lengths here. So this A isn't necessarily meaning this bottom side length here. We could say with respect to angle B, and then we would look at side length B. One thing to notice is just as in the triangle where the side length is across from the angle, the corresponding angle, the same is true for this equation here. So this little a, side length A, is across from angle A. Or in other words, the side length that you're solving for, or the side length squared by itself, is always going to be on the other side of the equation as whatever you're taking the cosine of, whatever angle you're taking the cosine of. And likewise, those two adjacent side lengths, B and C in this case, are also going to be together here, okay, on the same side of the equation. Last thing about the equation, this helps me remember this, is that you might notice, so again, we can rearrange these numbers, these quantities. So here's another example here, but with respect to angle C and side length C. I noticed that if I were to cover up this minus 2ab cosine C, that this is simply the Pythagorean theorem, right? A squared plus b squared equals c squared. In fact, the law of cosines it's arguably just another form of the Pythagorean theorem, but just for non-right triangles. In fact, if you were to try this on a right triangle, say cosine C is C is your right angle, well, we know that the cosine of a right angle, 90 degrees, is equal to 0. So this whole quantity here, this negative 2ab cosine C, is zeroed out. It cancels out, and we're left with just the Pythagorean theorem. So this is really the Pythagorean theorem, but for all triangles, not just right triangles. Okay, it's kind of a neat theorem. Okay, so we can use the law of cosines whenever we have a side or two sides in the included angle, or side angle side, or when we have all three side lengths. Okay, so what this might look like is if we have, so we'll say side angle side, that would be two side lengths. We'll call those A and B, and then the included angle, the angle right in between, we'll call that angle C. It also works for side, 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 and that's if we have all three side lengths, A, B, and C. We can use the law of cosines to solve for any of those angles, okay? If we have any of these two situations, side angle side or side side side, we can use the law of cosines to solve the triangle, okay? All right, so let's get a little bit of practice. Go ahead and flip the page. So number one, let's go ahead and solve for angle B. I notice that we have all three side lengths. The longest side is 19 centimeters, the shortest side is 10 centimeters, and the side length in the middle is 15 centimeters. Let's go ahead and solve for angle B. Okay, so as a reminder, the law of cosines, the quantity squared by itself is always going to be that side length across from the angle that you're taking the cosine of. They're going to be on opposite sides of the equation. So if we're solving for angle B, let's choose the side length across from B and have that be that quantity squared by itself. So that in this instance, this would be our 19. So we have 19 squared is equal to the other two side lengths, those adjacent side lengths, 15 squared and 10 squared. And then let's go ahead and subtract that to AC cosine B. So A is our 15, C is our 10, and then cosine of B. And we don't know what angle B is. That's what we're solving for. So we've got one equation, one variable we can solve. Let's go ahead and simplify or evaluate some of these values. We have 19 squared, we know is 361. 15 squared is 225. 10 squared is 100. Minus 2 times 15 is 30 times 10 is 300. And then cosine of B. 225 plus 100 is 325. And if we subtract that from 361, we're left with 36. Is equal to negative 300 cosine B. Dividing both sides by negative 300, we get the cosine of B is equal to negative 36 300ths. And we can reduce this. But let's go ahead and solve for B. In order to solve for B here, we have to take the inverse cosine of both sides. So taking the inverse cosine of both sides, the right-hand side just becomes B. That inverse cosine and cosine cancel each other out. On the left-hand side, we have inverse cosine of negative 36 300ths. And this is where you're going to need your calculator, so go ahead and take out your TI Inspire. I'm going to go ahead and open up a new document and open up a calculator. So we hit trig, inverse cosine of, I'm going to hit control divide to get a fraction, and we'll do negative 36 over 300. And as always, be careful to use that negative key, not the minus key. Our Inspire is going to give us an exact answer, so let's go ahead and hit control enter to get a decimal approximation. Double check that you're in degrees mode. So if you're in radians mode, to switch back and forth, you can always just go up to the top right with your cursor and click on where it says degrees or radians, and it's going to flip back and forth, as you can see here. So make sure you're in degrees. If you have to rerun the calculation, please do so. But we can find that the degree measure of B is 96.892 degrees. And we're rounding to the nearest thousandth, so that's 3 decimal places. So B is equal to 96.8, I think it was 892. Let me double check. 892, yes. And that's in degrees. Okay. So that's the answer to number 1. Number 2, solve for Q, side length Q, given that the measure of angle Q is 104 degrees, P is 26, and R is 23. Let's go ahead and draw this triangle here. And I noticed that the 3 letters that we have here are P, Q, and R. So I'm just going to go ahead and just label any of the vertices those 3 letters. It doesn't matter which one you label which, as long as you are assigning those values to the correct spots. So angle Q is 104 degrees. So I'm going to put that up here by angle Q. Side length P is 26. Remember, that's the side length across from angle P. And then side length R is 23. That's the side length across from angle R. So here we have side angle side. Yes, we can use the law of cosines. So to solve for side length Q, and I'll go ahead and label that too. To solve for side length Q, it's always going to be that side length. So the side length by itself in the equation is always going to be across from that angle that you have defined. So I know that we have angle Q, so that means that my Q squared is going to be the quantity by itself. So Q squared is equal to 23 squared plus 26 squared minus 2 times 23 and 26 cosine of 104. Okay? So we have Q squared is equal to 23 squared is 529. 26 squared is 676. And then 2 times 23 times 26 is 1,196. And then cosine of 104. Okay? So now we can just plug in this quantity into our calculator. And we'll get the quantity Q squared. So let's go ahead and plug that in. So we have 529. And then we have plus 676 minus 1196 cosine of 104. And actually, I'm going to use parentheses. There we go. Okay. Double check your calculator here. Notice that in this case, it's going to follow order of operations. It's going to do 1196 first times a cosine of 104, and then it's going to add all of these quantities together. Okay, so in this case, we don't need any extra parentheses because it's going to follow order of operations as we intend. So let's go ahead and hit enter. It's going to give us an exact value. So control enter is going to give us a decimal approximation of 1494.339. We'll round it. All right, so Q squared is equal to 1494.339. So square rooting both sides, the side length Q is equal to, let's go ahead and do that. I'm going to hit Control and the x squared key to get my square root. And then I'm going to just square root the answer that we just got up here, the 1494. I do that by hitting Control and then the negative key, and then hit Enter. We get 38.657 rounding. Okay, so 38.657. We don't have any units here, so I'm just going to write units. Okay. All right, so that's side length Q. One more, let's try a modeling problem. So a boy is flying 2 kites at the same time. He has 380 feet of line out to one kite and 420 feet of line out to the other. He estimates the angle between the two is 30 degrees. Approximate the distance between the kites. So I know that we're measuring this distance between the 2 kites. I'm going to call that distance x. Okay. So if we connect the 2 kites by a straight line, that's going to represent the distance between the 2. Okay, so I see this triangle here. We're trying to find side length x, and we have the angle across from it. So you guessed it, we've got side angle side. This is the law of cosines. We have x squared is equal to 380 squared plus 420 squared minus 2 times 380 times 420 cosine of 30. Okay. So we have x squared is equal to 380 squared is 14,440. Oh, I'm sorry, 144,400. I missed a 4 there. 420 squared is 176,400. 2 times 380 times 420 is 319,200 cosine of 30. Okay. We can go ahead and plug in this quantity into our calculator here. So we have, honestly, we could even plug in 380 squared, right? And then plus 420 squared. I'm going to go ahead and do that. And then we have minus 2 times 380. And then times 420. We have cosine of 30. So you can type it in exactly as you would write it out. It is going to follow those order of operations. So squaring first, then the multiplication, and then the addition. Okay, so if we hit enter, it's going to give us the exact answer. So let's go ahead and hit Control Enter. That's going to give us our x squared, 44,364.691. Okay, again, that's our x squared. So we have 44,364.691. And then if we square root both sides, then we get our distance of the kites. So square root of our answer. And we get about 210 feet, 210.629 to be specific. Okay, so x is equal to 210.629 feet. Okay. All right, so as a reminder and summary, our law of cosines is true for any triangle that we have, side angle side or side side side. Our quantity squared is always going to be that quantity across from the angle, that side length across from the angle that we're taking the cosine of, okay, and vice versa. Those adjacent side lengths are always going to be together on the same side of the equation, a and b here, and then also multiply together over here, okay? So this has been the law of cosines. We're going to get a lot of practice on this. If you have any questions, please leave a comment below, or you can send me an email. Otherwise, I'll see you tomorrow. Have a great day, everybody. Goodbye.